Hello, everybody. Now that we finally understand the difference between causation and association, let's talk about observational studies. This example will highlight the difference between causation and association quite well. Um, so in this study, we're going to be using the data that I've sort of provided here. We go ahead and we get this data from, what's the name of it? The National Health Interview Survey. So this is a real life data set, so it should be pretty nice for going ahead and talking about. So as always, when we go ahead and we do causal inference, we need to identify population. In this case, we'll go ahead and say USA. The entire population of the USA is the population of interest. We are going to be looking at an outcome. Our specific outcome is going to be a mean health score. It's going to be how healthy people are. And so I've already written down the two outcomes. Under the treated, it's going to be a lower score, and under the untreated, it's going to be a higher score. So we're going to be looking at mean health score. Now, the treatment in this case, a little bit odd, but is going to be a hospital. So those that are treated, A, is going to be those that went to the hospital, and those that are untreated, which is the A naught, are going to be not. And so notice A's, we get 3.21 versus the A naughts, the people that didn't go to the hospital, we go ahead and we get 3.93. And we're going to look for what the average causal effect is. So what is the average causal effect of going to the hospital? And we can go ahead and write this as Y sub A minus A naught. So we can just write this out quite literally. We've got 3.21 minus 3.93. So this is the group of people that were at the hospital minus the group of people that were not at the hospital. So we can go ahead and we can calculate this out. So this is going to give us a -7, basically, just -0.7. This is weird, right? We're saying that if people go to the hospital, they're going to be less healthy. What? Why would this be? And this is sort of our prime example of this idea that we had talked about before, which is causation versus association. It turns out that the reason why people go to the hospital is because they're sick in the first place. They're really sick. And so if you're really sick, you're obviously going to have a worse health outcome. And the people that didn't go to the hospital were probably the people that didn't need it. So in this case, what we're not looking at, causation. We're looking at association. So this is a perfect example of where causation does not equal association. So obviously, going to a hospital is going to, well, maybe not obviously, but it makes intuitive sense that going to a hospital will go ahead and actually increase your health outcome. So now we understand that causation is not association, and this is an incredibly important fact. So how do we go ahead and use this data? So we got this great data from examples in the wild. How do we go ahead and use this to go ahead and figure out what the causal effect of going to the hospital is? Well, it turns out in observational studies specifically, we need to go ahead and we need to make lots of assumptions that we're going to be going over rather quickly. And these assumptions will go ahead and give us the tools that we need to make this association claim into a causation claim. The number one assumption that we are going to be using is going to be saying, hey, let's go ahead and add randomness. And so in our example, causation does not equal association because people weren't randomly assigned to different groups. But if we go ahead and we sort of add this randomness assumption that people are randomly assigned to different groups, it will go ahead and make this observational study or these causation versus association differences very, very clear. Now, we can forfeit this claim of randomness and still make causal claims. But we're going to need a lot more information in order to go ahead and do this. Okay, so I hope you enjoyed sort of our example of an observational study, just getting data from hospitals, and sort of showing how important this causation versus association distinction is when looking at just collecting data out in the wild. And we note that the best way to go ahead and do this is, as we talked about before, do an ideal randomized experiment. And if we do that ideal randomized experiment, we can get that causal link. But without that, we'll need to go ahead and look at some of the assumptions that we will cover in the next video. So thank you for tuning in.